Greetings and welcome. We're talking about writing equations of circles, kind of based on some clues, and we're on page 628 of our text. Here is some student work that I really cut and paste, mashed together here on problem 29. And problem 29, what they did for us was they gave us 3 points that our circle passed through. All right? And the general layout is, let's see, first of all, let's verify that the student wrote the right points. So it's 7, -1, 11, -5, and 3, -5. So that's good, but bam. So the next thing that we do is we take general form of the equation of a circle, x squared plus y squared plus dx plus ey plus f equals 0. And we're going to plug in our x's and y's in for the x's and y's here 3 times. So plug in 1 point, so we've got the 7. That is a negative?
Yeah.
All right, let's make sure this counts as a negative. All right, good. Negative, oh wait. Well, okay, wait. Let's see. It would have been plus a -1 squared, right? So plus a -1 squared, which does become a +1. So that's important. Good. All right. Plus d times 7 plus e times -1 plus f equals 0. All right, good. Actually, F-Zero was a really cool game back on the Super Nintendo days where you had hover cars and you raced them. It was amazing. It was really cool. It was like pseudo 3D game back in the day. Let's see, then we plug in 11 squared plus a -5 squared. So yeah, definitely be careful with that. You did happen to either make 2 errors that somehow corrected themselves, but that's fine. And then 11, -5, 3, and another -5, so that would have been plus a -5 all squared will be positive 25. Okay, and good. So let's see what we've got next. So 7 squared is 49, -1 squared is 1, 7d minus e plus f. 11 squared is 121, 25, 11 minus 5, yep. 9, 25, that's a 3d. I like it. Minus 5e, good. And then you combined 49 and 1 and got 50? Okay. And subtracted it from both sides. So that's our first mistake. Well, our first true mistake. These were mathematical communication mistakes.
Oh, I added 7. I added that 7D.
Oh, you added the 7 to it.
Oh, that's so.
Okay, so yeah, the 7 was its own thing. That would do it. Good catch. I didn't see where that mistake came from, so I'm glad you spotted that. So 11d minus 5e plus f equals, let's see, 121 plus 25 is 146. And hopefully this is a negative 146.
Yeah, it is.
I think so.
You can see the little line right here?
I did. I'm just making it clearer for our viewers. That's all. And then let's see, 9 and 25 is 34, and you'd subtract it, so negative 34. So I'll just kind of clear this up for our viewers. All right, and so then we've got 3d minus 5e plus f. So the value of this is that now we have a system of 3 equations and 3 unknowns. And we're going to solve this any way we know how. Actually, you know what we might do? I'm going to solve this using, I could solve this on the calculator using matrices if we wanted, or I don't know, what do you guys think? Or let's further analyze this, I guess, see if there's any mistakes. So it looks like you went for opposite f's, which works. So you got a negative b equation, a negative f equation. So let's see, so that's fine. Good. And then you did a minus b, and this would have been 50. So yeah, this number would have been wrong, and then this number would have been wrong. And so by eliminating the same variable twice, you end up with 2 equations and 2 unknowns. And then you can kind of solve that using your other techniques because we know how to solve that. So it looks like you happen to have a convenient elimination situation maybe by the looks of it, yeah. And you found E, which wouldn't have been that. But let's see, actually let's find out if we can maybe tweak this a little bit. So let's see, what was the thing that would have been wrong? So this would have been negative 50 plus 146, so this would have been what, 90,
4,
96. Yeah, 96, right? And this one would have been negative 50 and 34, so that would have been negative 26. Nope, negative 16, right? I think. So we would have had 16 and 96, negative 16. So when I added those, that would have been 80. And I would have gotten E equals 10. Okay? So, anyone get E equals 10? No. And it's unfortunate, I can't tell what the book got for D, E, and F because those aren't even the final answers. So then I would have plugged 10 in here. I would have had 4D plus 4 times 10 is 40. Negative, actually now this negative 23 is wrong too, isn't it? Was that one of the wrong ones? It's negative 16.
Yeah.
Yep, okay. So this would have been minus 40. So it would have been, oddly, wait a minute. Did that somehow work out right-ish? Did you happen to, wait, because this would have been 40. Minus 40 from negative 16 would have become negative 56. That's weird that that was almost the right number. And so this would have been negative 14. Is that right? Yeah, that sounds right. So there's DE.
Yeah, that one was like the only believable one.
And then here, this is the negative 50. And so you plugged in negative 10. And what was the answer? It was negative 14, was it? Was what I just said, I think. So 7 times negative 14, let me do some of this out. Negative 98. Minus 10, is that a minus 10, I hope?
Yeah.
So negative 108. Add that to both sides, so you'd have negative 50 plus 108. Is that going to be 58, I think,
Yeah.
for F? All right, so we just found D, E, and F for this, and now what we'd be able to do is plug them in and put this in standard form. So let's do that together. I won't be able to redeem this very well, but it looks like, so you had that, you gathered your X's, you gathered your Y's. Wow, this would have been a real pain, dividing that by 2 and squaring it and trying to complete those squares. It would have been challenging. You forgot to have your squares here when you did that, and then you found your center, which was the opposite of that, the opposite of that. Your radius would have been the square root of this. So you had the general outline. I probably, if this was a test question, you probably would have only lost like 1 or 2 points out of 5. So that's not bad. Like, you definitely understood the whole layout, which is key, right? And just a single sign error. There's my finger. That's pretty awesome. So let's see. So we'll have x squared plus y squared. D was 14, so minus 14x. E was 10, so that's plus 10y. And F was 58 positive. Equals 0. So I'm glad we're able to redeem this a little bit. X squared minus 14x blank plus y squared plus 10y blank equals negative 58 blank blank, right? So I'm moving in for the double complete the square kill here. Here we go. Combo move. Here we go. Here we go. So negative 14 divided by 2 all squared. It's going to be negative 7 all squared is 49. By the way, this parentheses is valuable. Otherwise, you actually would have gotten a negative 49. So add 49, add 49. Hopefully this is going to be a positive by the time I got to dig myself out of this negative hole. And let's see, find this new C term. So that's going to be 10 over 2 all squared. It's going to end up equaling 5 squared or 25. So I'll add 25 here, add 25 here. And so now when I complete factor this and factor that, I'll have something all squared plus something all squared equals whatever this adds to. So this will end up being x with a negative 7, x minus 7. And this will be y plus 5 all squared. And let's see, 49 plus 25. 74 minus 58, I get, 16. How convenient. So that means my center is 7, negative 5, and my radius is the square root of 16, or 4. And this all would be my answer. So that problem is a beast, and as you can see, a single mistake can completely spoil the whole problem. I'm glad we were able to redeem it. We got the right answer all together here. So thank you, viewer, for being able to see some other students' work and be able to learn from it. It actually will help you understand the problem better and the potential pitfalls on it. So let's keep trooping on here. So here's some other clues. Now I'm looking for another circle as a detective here. Circle detective. Actually, I need to make like a cool like circle detective badge or something. Like it'd be like all awesome, and it'd be like circle detective, and it'd be all official. Maybe it'd be like a shield or something, but with a circle. Like it'd be like circle detective. Man, that'd be so great. And then when kids pass the test at the end of the chapter, like they get the badge, they feel all proud of themselves. So let's graph this. Let's get an idea of what this looks like. Negative 2, 3, and negative 6, negative 5. Yeah, so I pretty much have to go out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Bam. So over 2, up 3 is right there. Backward 6, down 5. Ooh, goodness. Why, thank you, friends. And internet friends, you can write bless you in the comments, and I thank you for those as well. So let's see, here's the endpoints of a diameter. So this is super key here. Super key. So my circle's diameter is that. So if I want to find the center and radius, number 2. Why, thank you. Let's see. I'm gonna. No one likes a Mr. Sniffles here. Just a second. I'm so glad to have the sound of my boogers recorded on the internet now. Yep, I've always wanted that to happen. This video is gonna have so many likes. I hope someone like takes that sound and like puts it to dubstep. So let's see. So my center is going to be right here somewhere. So to find my center, I could actually use the midpoint formula between those, I believe. So midpoint is equal to, or maybe colon would make more sense, is the same as the center in this case, right? So we'd have the average of the x's, 2 plus negative 6 over 2, comma, 3 plus negative 5 over 2, comma, right? Well, no comma, close parentheses. So the center is going to be, let's see, negative 4 over 2, comma, and what's that? Negative 2 over 2. So it looks like that becomes negative 2, negative 1 is my center.
Yeah, I got that.
Nice. And now I need to find the radius, and I've got a couple options. I could find this entire distance, which would be the length of the diameter, and then divide that by 2, and that would give me that distance, right? Or I could find the distance from my center to my either endpoint of the diameter, and that would also give me the radius. Or I could plug in the center for h and k, I could plug in this for x and y, and I could solve for the radius in the equation of a circle. But distance formula probably makes the most sense. So distance equals radius equals the square root. I like how my r's sometimes start to look like square roots. Isn't that great? It's like slowly evolving into the square root. So the square root of x2, so I'm going to actually, let me label these. I'll call this my x1, y1, and I'll use this as x2, y2, just for fun. So let's see, x2 is 2 minus x1 is negative 2, careful with your double parentheses, plus y2 is 3 minus y1, double parentheses again, like so. Let's see, extend that vinculum. So equals the square root of 2 minus negative 2 is positive 4 squared, plus 3 minus negative 1 is positive 4 squared. Wow, interesting. So that's 16 plus 16, which is 32. And I can actually break that down into the square root of 16 times the square root of 2, or 4 square roots of 2, if you want a reduced radical version of it.
So that is the answer?
Well, that's the radius.
Oh, no, then I got the problem.
So the square root of 32 or the square root of 4 square roots of 2, if you estimate that in a calculator, is 5.66. If you wanted to, like, if we had to graph this. Did we have to graph this? No, we didn't. But we still need to write the equation. I've just found HK and R, so now let's plug it into the equation of a circle. So I'll have, foreshadowing. X, it'll be minus h all squared plus y minus k all squared equals r squared. The square root of 32 squared, or 4 square roots of 2 squared, either way is just going to equal regular old 30 dose. And minus 2 minus 1 will become plus 2 and plus 1. So there's my equation right there. So that's a classic. Fortunately, for pretty much the entire chapter, whether we're working with circles, ellipses, parabolas, or hyperbolas, you'll have that opposite sign concept. So eventually we'll get really used to it. I assume that's the right answer, 35. Was that the problem I did, right? X plus, wait. Oh, was it? No, 37 I did. Here we are. Yeah, and we're good. I like it. And last problem. All right, this one's really interesting. I might actually open up my graphing software for this one real quick, just to better detail this situation more fully. I've been given the equation of a tangent line that is not just a straight vertical. Let's see. Oh boy, I'm getting some lag here. Just as my graphing software is opening up. Just a second. Here we go. Okay. What I might do is write that in y equals mx plus b form, just in a moment. So I'll have x plus 3y equals negative 2. I'll have 3y equals negative x plus 2. So y equals negative 1/3 x plus 2/3 is the equation in slope-intercept form. And what they've told us is, let's see, opening up a new sketch. Here we go. And I'm going to graph negative 1/3 x plus 2/3. All right. And what did they tell us? They said the circle is tangent to this line, and it has its center at 5, 1. Okay? So let's check this out. So here's my line. I'll hide these guys. Command H. I might even bump that up to medium. Let's see, and let me plot some points. Plot, 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 plot. There we go. My son's favorite word is plop because I taught him how to throw rocks in a river once, and he says plop all the time. Bam. So, so here we go. This is what I've got. So the circle passes through here and is tangent to the line. Now, tangent, all right, means that it's going to just barely touch that line once. So this would be too much. This would be not enough. It's going to look something like that. All right, technically I could probably even, no, that would still end up not working. And it turns out there's, let's see, oh dear. What did I do? Can I redo? Redo? Okay, whew. All right, there we go. I was scared for a minute. You guys were scared to admit it. It's okay. So it turns out the radius, here's a cool fact about circles, geometry, right? The radius from the center to a tangent line is going to be perpendicular to that tangent line. So watch this. If I construct a perpendicular line, if it lets me. Come on, perpendicular, perpendicular. Construct. It's not giving me the option. That's really weird. Do I have something else selected? No. No, it's for some reason the program isn't doing it right. But that's fine. Let me just steal this graph. and we'll be good. Paste. Yeah, I'll just throw it down here.
Yeah, that's what I just put down.
Did I mess up?
Sure, yeah.
Oh, thank you. Good catch. Negative 2/3. Good catch, friends. Good catch. So it was minus 2, and then y equals negative 1/3. X minus 2/3. Okay, good call, good call. So let's go back to our graph. I think I can just change this to negative over here and hit enter. That is not what I meant to do. What? Oh, I lost the X, that's why. Classic. Okay, so here we go. Now we've got a little bit more space that I need, and snapshot. Click, click, paste. There we go. So it turns out that this segment from the radius to your tangent line is going to be perpendicular. Okay, is the idea. And then you'd have your circle kind of be in from there. All right, so that's a fact. So let's see. What do I know? I know the center. I just need to find out that radius, right? Is this, how crazy is this going to get? I think this is going to get crazy. Guys, this is going to get crazy. Algebra's, yeah. I need to find the equation of this orange line and then find the intersection of the orange line and the purple line. That's what we need to do. So to find the equation of that orange line, like I said, the slope, these lines are perpendicular. What is the slope of this first line? Negative 1/3. So the slope of a line that's perpendicular to that is going to be the opposite reciprocal. So it's actually going to flip it and change the sign. I'd get the slope is positive 3. And I know that this second line passes through my center at 5, 1. So I'm going to currently find the equation of a line that has these two facts. So ready? This is going to be back old school algebra 1 style. So in y equals mx plus, actually let me write this in green. For y equals mx plus b, I'm going to plug in what I know, solve for what I don't. Okay? What do I know? I know m is 3, and I know the point 5, 1 exists on it. What I don't know yet is b. I'm looking for b. Looking for love in all the wrong places. Here we go. So 1 equals 15 plus b. b is going to equal negative 14. Okay? So the equation of my second line has m3, b negative 14. So y equals 3x minus 14. Just to verify for you, I'm going to come back to the screen in a minute, so I'm going to be over here writing for just a second. What did I just say that was going to be? It was going to be, oh, there we are. I'm in the way. Let's see. 3x minus 14. So 3x minus 14. Look, we did it. Hey, look, I found exactly the right line. Those lines are perpendicular. They pass through it. So what I need now is to find the intersection between those two lines and then find the distance between those 2 points, because that distance is going to equal my radius. All right, so that's what we've got. So I've got now this line, y equals 3x minus 14, and this line, y equals negative 1/3 x. Actually, you know what? I'm going to use this version of it. X plus 3y equals negative 2. X plus 3y equals negative 2. And this line, y equals 3x minus 14. I'm going to solve this by substitution because this one's already solved. I chose the non-fraction version just because I could. I'm going to plug that in here. And I'll get x equals 3 times, nope, x plus 3. Equals negative 2. Distributing, x plus 9x minus 3 times 14 is 30 plus 12, 42, equals negative 2. 10x equals 40. Dylan, would you mind closing the door for a second? I'm just recording a video. So let's see, x equals 4. So that means, all right, that my x-intercept of this point is 4. It looks like the y-intercept is going to be negative 2. Let's prove it, though. Prove it. Let's plug that in here. Man, all of our skills are coming back to haunt us. Isn't it great? Y equals 12 minus 14. Oh, yeah. Y equals negative 2. So, what does this mean? That means that a point on our circle is 4, negative 2. All right, so this is a point on circle. Right, but if I plot that point, okay, and draw the circle to that point, that's the tangent point, and I definitely have a circle that had that center and was tangent to that purple line. And now I just need to find the radius so I can find out what the equation of this circle is. So the next step, let's just find the distance between our 2 points. So let's do that. Distance, and I'm running out of room, 4, negative 2, and 5, 1 was the other point, right? So 5, 1, let's distance this. x1, y1, x2, y2. So here we go. I'll have distance, or radius in my case, is equal to 5 minus 4 all squared. You're coming down to the line here, plus 1 minus a negative 2 all squared equals the square root of 1 squared plus 3 squared. Oh, here we go, here we go. Square root of 1 plus 9, square root of 10. So, between my center and my radius, I can now write my equation. X minus 5 all squared plus y minus 1 all squared equals the square root of 10 squared, which is 10. Whew. That one was quite the mystery. That actually required some serious Algebra 1 skills. Back in the days of Algebra 1, Math 1, the problem of finding the equation of a line perpendicular to another one through a point is probably like the toughest question on that particular chapter that would have been taught about equations of lines. So yeah, that's a good question. Good problem right there. And then we had our circle, which was wonderful, which actually, yeah, we'll just pretend there's the circle, and he's happy now. So thanks for watching, Internet friends. Hope you had a great time. Bless you too, guys. Bless you too.